You're now going to review two more AWS services that you can use with containers. These services are AWS Fargate and Amazon Elastic Kubernetes Service, or Amazon EKS. You're also going to learn about AWS step functions. AWS Fargate is defined as a compute engine for Amazon ECS and Amazon EKS, and as such, it can be used with ECS to run containers without the overhead of needing to manage any servers or clusters. In this way, ECS can use containers that are provisioned by Fargate to automatically scale, load balance, and manage the scheduling of your containers for availability. Fargate provides an easier way to build and operate containerized applications by removing the need to choose server types, decide when to scale your clusters, or optimize cluster packaging. You can run both Fargate and ECS tasks in the same cluster. Fargate capabilities are available natively in ECS, so you don't need to learn new API actions to run containers on Fargate. Fargate is available with 50 different combinations of CPU and memory to match the needs of your application. You can use between 2 GB and 8 GB per vCPU to enable various configurations. So you can best match workload requirements, whether they are general purpose or compute or memory optimized. You pay based on the task size, and you also pay only for the time resources that are consumed by the task. In terms of granularity, the price for CPU and memory is charged on a per second basis, but be aware there is a 1-minute minimum charge. You will now learn about the components of the Fargate and Amazon ECS stacks in a sample deployment. First, you create a task definition that defines how ECS handles scheduling and orchestration. Fargate manages the placement engine, the cluster, and also the infrastructure. The resources that are managed by Fargate include agents, AMIs, and other resources related to the Fargate service. To help you visualize this, consider what happens when a new version of Docker is released. If you don't use Fargate, you must think about an upgrade strategy and then manually upgrade the version of Docker on each node in the cluster. This process would require draining that node, scheduled downtime, and so on. With Fargate, all these tasks are taken care of on your behalf. Amazon ECS has two modes. You have the EC2 launch type and the Fargate launch type. With the Fargate launch type, all you need to do is package your application in containers, tell it what the CPU and memory requirements are, define your networking and IAM policies, and then launch the application. Fargate manages all the scaling and infrastructure that are needed to run the containers in a highly available manner. Running containers as Fargate or as EC2 is a launch time decision. You don't need to add any additional plugins to run containers as Fargate. In summary, with Fargate, you no longer need to provision, configure, or scale clusters of virtual machines to run containers. If you want to get a service or application up and running quickly, Fargate is a good way to make it happen. That is, you write your task definition, choose Fargate, and your application is up and running. Here's another use case. Say that you must quickly migrate a monolithic application to the cloud. By containerizing the application and then launching it with Fargate, you can concern yourself less with the cluster and instead focus on the application itself. Another use case for Fargate is when your service or application is highly variable but unpredictable in the resources it might use over time. Fargate can add additional infrastructure capacity automatically, according to whatever bounds you set. So you don't need to worry about your service running out of resources and becoming unavailable, and you don't need to over-provision resources for the highest possible demand and end up paying for resources that you don't need. With this in mind, why might you still want to consider using EC2 mode? You might choose to use EC2 mode for your Amazon ECS tasks if you are a heavy user of EC2 spot instances, or if you paid for reserved instances. Fargate manages all the infrastructure on your behalf. Because it's charged by the CPU and memory second that's consumed, there is no way today to apply these features across spot instances or reserved instances. If the services and applications are based on Microsoft Windows, EC2 mode is still probably the best option for deployment because you can use Windows AMIs and configurations in your cluster, which Fargate doesn't support currently. And finally, if you need more granular control of your EC2 instances, then EC2 mode is the clear choice. The need for granular control could come from compliance or governance requirements, or because of broader customization options. Now, you'll learn about Kubernetes. What is Kubernetes? It's open source software for container orchestration. It enables you to deploy and manage containerized applications at scale, and it uses the same tool set on-premises and in the cloud. Kubernetes works by managing a cluster of compute instances. It runs scheduling containers on the cluster based around where compute resources are available and the resource requirements of each container that will run to support your applications. Containers are run together in logical groupings called pods, and scaling up involves increasing the number of pods for an application. The Kubernetes software decides when and where to run the pods. It manages the traffic routing and scales your pods based on utilization or other metrics that you define. In terms of resourcing, Kubernetes automatically starts pods in your cluster based on their resource requirements. It will automatically restart pods if they fail or if the instances that they run on fail. Each pod is given an IP address and a single DNS name, and Kubernetes uses this to connect your services with each other and also with external traffic. The main function of Kubernetes is to enable containerized applications to run at scale across a cluster of servers. It's easy to move applications from local development machines to production deployments on the cloud using the same tooling, and this is one of the key advantages of Kubernetes because it can be used to run containerized applications anywhere without needing to change the operational tooling. Because it's an open source project, it's easy to add new functionality to Kubernetes. There's a large community of developers and companies that build extensions, integrations, and plugins that help Kubernetes users do more. In AWS, you can either manage the Kubernetes infrastructure yourself by running it on EC2 instances, or you can use an automatically provisioned, managed Kubernetes control plane with Amazon EKS. EKS makes it easy to deploy, manage, and scale containerized applications. It runs the Kubernetes management infrastructure across multiple availability zones to eliminate a single point of failure. EKS is certified Kubernetes conformant, so you can use existing tooling and plugins from the AWS Partner Network, or APN, and the Kubernetes community. Applications that run on any standard Kubernetes environment are fully compatible and they can be migrated to EKS. The diagram shows how EKS works. First, you create the cluster with the parameters you need, such as the VPC and subnet IDs. Next, EKS automatically deploys Kubernetes control plane nodes. Next, you deploy worker nodes. You add the number of worker nodes that you need to your EKS cluster. Then, you connect to Amazon EKS and point your preferred Kubernetes tooling at your EKS cluster. Finally, you deploy your Kubernetes applications to your EKS cluster. Now you will learn about Amazon Elastic Container Registry, or Amazon ECR. ECR is a fully managed Docker container registry, which makes it easy for developers to store, manage, and deploy Docker container images. It's integrated with Amazon ECS, so you can store and run and manage container images for applications that you run on ECS. You can specify the ECR repository in your task definition, so ECS can retrieve the images for your applications. ECR supports Docker Registry HTTP API version 2, and this API enables you to interact with ECR by using commands through the Docker command line interface, or by using your preferred Docker tools. Thus, you can maintain your existing development workflow and access ECR from any Docker environment, whether it's in the cloud, on-premises, or on your local machine. ECR stores your container images in Amazon S3, so it benefits from the high availability and durability of S3. You can use namespaces in your ECR registry to organize your repositories based on your team's existing workflow. And you can set the API actions that another user can perform on your repository. You can share your repositories with different users and AWS accounts. ECR uses IAM for access control, so you can control which EC2 instances or users can access your container images. You can take advantage of HTTPS to transfer your container images to and from ECS, and images are automatically encrypted at rest with S3 server-side encryption. And lastly, there are many third-party tools that can be used with ECR. Next, you'll learn about using AWS step functions in serverless workflows for system operations. With AWS step functions, you can coordinate multiple AWS services into serverless workflows. This means that you can build and update applications quickly. For example, you could design and run workflows that combine services like AWS Lambda and Amazon ECS into feature-rich applications. These workflows are made up of a series of steps, with the output of one step acting as the input for the next step. Step functions translates your workflow into a state machine diagram that is easy to inspect and understand, which makes it easier to explain to others and easy to change. You can monitor each step as it happens, which means that you can identify and fix problems quickly. Step functions automatically trigger and track each step. If there are errors, step functions will retry so your applications run in order and as expected. To read more about step functions and see architectural examples, search for Step Functions Use Cases in the AWS documentation. Here's an overview of how to work with step functions. First, you define the workflow. The individual tasks are then represented as a state machine. Individual states make decisions based on their input, perform actions, and then pass their output to other states. The step function console gives you a graphical representation of the state machine to visualize the application logic. States can perform different functions. For instance, they could do work like performing a task, or they could make a choice about which branch in the workflow to continue on. It's possible to configure tasks to invoke code that is hosted in a Lambda function, a container, or an instance. The code can then be run as many times as needed for a period as long as 1 year. And as workflows evolve, you can change the tasks, change the step order, add tasks, or delete tasks, all without needing to make any code modifications. And that's it for now. Thanks for watching, and see you in the next video.